A very warm welcome to you all. This session helps you to understand about how the data mining works exactly. The learning objectives of this session are, by the end of this presentation, the learner will be able to recall what is data mining, and finally the learner can understand the process of knowledge discovery in databases clearly. So first recall what is data mining. Data mining, which is also be called as knowledge discovery in databases, refers to extracting or mining of knowledge from large amounts of data. As you can see here, large amounts of data will be available and the users wants to mine the valuable knowledge from its large databases. So the extracted knowledge must have some characteristics to make it useful for decision making purpose. So the knowledge must have the characteristics non-trivial, that is, it must be extracted by applying some sort of complex operations, not of simple retrievals. And the knowledge must be implicit, that is, it must be the hidden knowledge within the information that is existed in the databases. And the knowledge must be previously unknown to the user. And finally, the knowledge must be useful to make decisions in the future. And this slide shows you the overview of the KDD process. As you can observe here, initially we have large amounts of data and finally it will be converted into the knowledge. So this entire the KDD process will have majorly 6 steps. One is selection, pre-processing, transformation, data mining, interpretation and evaluation, and finally the knowledge representation. So let us explore all these 6 steps in detail one by one. So the step 1 of the KDD process is the selection process, that is, the user must develop an understanding of the application domain on which he wants to apply now the KDD, and he wants to understand what type of knowledge he required, that is, what is the goal of the end user from that large databases. So from the large database that is available, the user has to create the target data set, that is, selecting the data set or the data samples on which discovery is to be performed. So you can observe here in the diagram, initially we have the large databases on which we need to apply some sort of selection process depending on which we want to extract the knowledge, and from this selection process the target data will be created on which knowledge discovery process will be applied. So this is the initial step of the KDD process. And next, the next step in the KDD process is pre-processing, that is, the processing which will be applied on the target data to make it the data which is useful for knowledge discovery process. The pre-processing step is also be called with the name data cleaning. So what this pre-processing or data cleaning exactly consists of is, it deals with the missing values and it identifies the outliers and smooth out the noise data, and finally if any inconsistent data is existed, the inconsistent data will be converted or corrected into consistent data. So what exactly the filling in missing values is, the data, the target data that is collected by the user may have some sort of values that are not available. So that not available or null values in the data set must be filled with some sort of values. And that selected data may consist of some sort of outliers due to noise in data collection tools. So that outliers are to be identified and that outliers or noise data is to be smoothened out. Finally, if any sort of inconsistency or wrong values are existed, those can be corrected into the correct values. So this is the second step of KDD process, which is crucial because if the data is accurate, then only the identified knowledge will also be that much of accurate. So the accuracy of the knowledge that is identified from KDD depends on the accuracy of the data set. That's why pre-processing plays a major role in the entire KDD process. The next step, that is step 3 of KDD process, is data reduction and transformation. As the name indicates, the pre-processed data may have the larger size in which the KDD process may take more time. So this preprocessed data, which is of large size, is to be transformed into another form which is of a very small size without losing any characteristics or any properties that are existed in the preprocessed data. So this data reduction or transformation consists of majorly 5 internal processes. One is data cube aggregation, which is the data which is in the detailed format, if required, can be converted into aggregated form. That is, for example, if I consider the sales data of a particular supermarket, and if that sales data is existed as day-wise sales, if we want that, we can convert into month-wise sales, or we can convert into quarter-wise sales, or we can convert into half-yearly sales also. So reducing the size of the data by applying aggregation operations is called as data cube aggregation. And the second one is dimensionality reduction. The dimension means here the attribute. The preprocessed data set may consist of number of attributes to describe the properties. So as the number of dimensions increases, applying the processing on this high dimensionality data may also require more time. So the dimensionality reduction is also be very important, again without losing the original characteristics of the data. The third one is data compression. As the name indicates, we need to reduce the size of the data that is occupied. And the next method in data reduction and transformation is numericity reduction. As the name implies, it reduces the number of distinct values in a particular attribute of the data set. That is, if we have the age values as individual values, we can convert that age values which are individual values into categories like young, middle, senior, etc. And finally, concept hierarchy generation. If any attribute, not only numerical or categorical, if consists of more number of distinct values, by generating the concept hierarchy, we can convert it into small number of values. So the main aim of all these 5 steps is reducing or transforming the data which is suitable to the next task. The next step of the KDD process is the most important, which is the data mining task. As you can observe here in the diagram, on the transformed data, which is the result of the previous step, data mining is applied to identify the patterns which are existed within the transformed data. So in this data mining task, what the user has to do is, depending on the goal of that user, that is what type of knowledge he want to discover, he has to choose a data mining task. That is, deciding whether the goal of the KDD process is classifying the data, or identifying the association rules in the data, or categorizing the data based on the similarities, that is clustering, or whether the user goal is just detecting the outliers that are existed in the data sets or in the databases. So depending on the goal of the user has to select the data mining task in this particular process. So you can identify here in the total KDD process, the most important step is the data mining, which is identifying the type of pattern that is required for the user. The next step of the KDD process is interpreting the mined patterns. So you can observe in the previous step, that is in the data mining task, by applying a data mining functionality, the knowledge will be retrieved or the pattern will be retrieved from the transformed database. So here the identified patterns will be evaluated by considering some parameters. So strictly here, interesting patterns represents the knowledge and are identified based on the given measures. That is, for every type of pattern that is identified, we need to apply some interesting measures to decide whether that pattern will become a knowledge or not. So consider an example. If your patterns are in the form of association rules, you can consider the measures support and confidence. Support implies this pattern will be supported by how much percentage of the existing data, and confidence will implies that the probability that this pattern will become true in future. If I consider the pattern as classification model, the interestingness measure can be considered as accuracy, that is, the percentage of the test set samples that are correctly classified by the identified patterns. So in total in step 5, evaluation means the identified patterns will be evaluated whether it becomes a knowledge or not by considering some sort of interestingness measures. And these interestingness measures may be different from one type of knowledge to another type of knowledge. Last but not the least, the final step of the KDD process is visualizing the discovered knowledge. That is, if the pattern becomes interest in the previous step, it becomes a knowledge, and that knowledge is to be presented or visualized to the end user. So to visualize the discovered knowledge, we have various representations. One is the list, trees, or semantic networks, which is an example graph representation, or the identified knowledge can also be represented in the form of rules or in the form of some sort of logic representations. So here is an example of simple tree-like representation of the knowledge visualization. So finally, at the end of this presentation, the summary that we have covered is data mining is the extraction of knowledge from large amounts of data, and the total process of knowledge discovery in databases consists of total crucial of 6 steps, which is the data selection, that is from the large amounts of data, focusing on the targeted data, and the next one is the data pre-processing, that is the targeted data is to be cleaned to make it as the pre-processed data which is useful for knowledge discovery purpose. And the third one is the data transformation, which is converting the data into a suitable format. And the next one is that applying the suitable data mining functionality depending on end user focus. And the next one is interpretation and evaluation, that is evaluating the identified patterns whether it becomes interesting patterns or not. And finally, if the pattern becomes interest, it becomes a knowledge which is to be visualized in a format that is suitable or easy to understood to end user. Thank you for your attention.